In this slide, we will discuss the tensile property requirements for ASTM A615 and ASTM A706 according to tables we have in ACI 1825. But before that, I'd like to draw your attention to this diagram from Dr. Jack Moehle's book. In this diagram, we see that the yield strength has been plotted a little higher than what we expect in all grades for different rebar types. This difference is generally due to probable issues with the rebar production procedure. Producers usually aim for an actual yield strength higher than the minimum value so that given variations in properties, there is only a small chance of the actual yield strength falling below the minimum value. In this table, which is the report data on actual bar properties from the mill test, you can see these ratios. For example, the ratio of actual yield strength to the nominal yield strength for ASTM A615 can be even up to 1.4. This idea is so important, and we as a structural engineers should keep it in our mind. The next important ratio that I'd like to talk about is the minimum ratio of the actual tensile strength to the actual yield strength. We can find this ratio on the ACI 18 tables. As you see here, for all grades of ASTM A615, the code defines this ratio to be at least 1.1 to ensure that the tensile strength has enough distance from the actual yield strength. Be careful that in this ratio, the actual yield strength and the actual tensile strength are important, not the minimum yield strength or the tensile strength. This is an important point to have in your mind. The ASTM A706 ratio is a little bit higher than the ASTM A615. What is the reason behind this ratio increment? What do you think about it? Tell me in comments whatever comes into your mind, and like the video if you think this video deserves it.